Hello everyone, my name is Jimamol PS. Today I would like to discuss with you on the topic is Ballistic Galvanometer. As introduction, what is meant by a Ballistic Galvanometer and its construction, principles, advantages and disadvantages, and for the last, its conclusion. Introduction. What is a galvanometer? A galvanometer is an instrument used to detect and measure small electric currents. You can see here different types of galvanometer, a moving coil, a mirror galvanometer, an astatic galvanometer, and finally ballistic galvanometer. What is a ballistic galvanometer? A type of galvanometer that measures small amount of electric charge over a short period of time. It can be either moving coil or a moving magnetic type. The uses are, it detects the presence of current in the coil in the Wheatstone bridge. It can measure current by connecting a low resistance in parallel to it. It can detect voltage by connecting high resistance in series to it. It is used for detecting communication cable errors. This is an image of a ballistic galvanometer. The inner construction are here. Finally, its construction. A ballistic galvanometer consists of a circle, a rectangular coil of a copper wire of almost 10 to 15 turns. This coil is suspended in a radial field between concave poles, pieces of a strong magnet. When the coil rotates in the magnetic field, an EMF is induced across the coil according to the Lenz's law. It opposes the motion of the coil, and this is known as the electromagnetic damping. To minimize the electromagnetic damping, the coil should be wound on a wooden frame, and the whole suspension is enclosed in a metal case provided with glass face. And here is the construction of a ballistic galvanometer. You can see two permanent magnets here, lower suspension and upper suspension, and a mirror is placed there. The deflection of a ballistic galvanometer and its time period and its working principle. The coil starts moving when the charge flows through the coil. It gives rise to a current due to the torque produced in the coil. Working principle of a ballistic galvanometer is that charge measured by the ballistic galvanometer must be passed through the coil. When the initial kinetic energy of coil is completely used in doing work, the coil starts moving back to its original form. Thus, the coil oscillates in the magnetic field and the deflection is noticed from which charge can be calculated. This torque acts for a short time. The product of torque and the time period provides a force to the coil and the coil starts rotating. You can see here the working principles. Two magnet is placed, moving coil and an eye core. Disadvantages and advantages. First, we're going to look for the advantages. The scale is linear. It is high sensitive. The measurement is accurate and precise. The torque to weight ratio is high in a ballistic galvanometer. This avoids errors. It's not affected by stray magnetic field. When it comes to the disadvantages, limited range. It can be only measured in small currents. Fragility, it means the moving parts can be delicate and susceptible to damage. Temperature sensitivity. The temperature change can affect the readings, leading inaccurate and requires calibration. Regular calibration is necessary to ensure accurate readings. Can't measure AC current. It can be only used in DC currents. And finally, the conclusion. A ballistic galvanometer is the amount of charge that passes through the coil is proportional to the deflection of the coil. This is because the coil deflection is based on the amount of charge that passes through it. The coil moment of inertia, which resists the angular momentum. So here I am concluding the presentation. Thank you so much.